Hey everyone, welcome to our lesson on solving systems of equations using elimination. I wanted to show you some possible types of solutions you may come across when you're solving systems of linear equations. This first one here on the left has one solution because there's one point where the lines are intersecting. The one in the middle here has no solutions because there are parallel lines and they are not going to intersect at all. This last one here seems to appear as if it is one line, but it is actually, this can happen sometimes where your lines are overlapping and they're in the exact same spot, so they have infinitely many solutions because they're touching everywhere. Alright, so when we're going to solve our systems using elimination, the idea is to eliminate or get rid of one of our variables so that we can solve for the other variable. So I have a system here for us to look at, a system of linear equations. 2x minus y equals 7 and 3x minus 4y equals 8. And we have to first choose which variable we want to eliminate. So for this example, I've chosen the y. I want to get rid of the y first. In order to do that, I'm going to have to make the y coefficients be the same number but opposite signs. That way when I add my equations, they will eliminate. They will disappear. Okay, so I'm looking at the y's here, and I have -1 and -4 as the coefficients. So I'm going to create a new equation where the top one of my equations has a positive 4y there. Alright, so in order to do this, I'm going to need to multiply that -1 in front of that y by -4. So I've shown you that here. And I have also just rewritten the whole entire equation beside that -4 because if you're going to do this multiplication on one term, you have to do it to every term in your equation. So we're going to make a brand new equation here after we've multiplied this -4 by every term. And that's what we have here. We have -4 times 2x gives me -8x. -4 times -y gives me that positive 4y that we wanted. And then -4 times positive 7 gives me -28. For the bottom equation, I'm not going to do anything this time. I'm just going to rewrite it underneath my new top equation. 3x minus 4y equals 8. And now I'm going to add the two together. Once you have made one of your variables have the same number in front but opposite signs, we're going to add, and what's going to happen is it's going to be eliminated because 4y added to a -4y is 0. So I have -8x plus 3x, which gives me the -5x here. And then on the other side of the equal sign, we've got -28 added to 8, which gives us -20. We're going to continue to solve. We need to isolate x. This is what we're solving for now because we've eliminated y. So divide both sides by -5, and we have our x value. Now we're not quite finished. We need to solve the system, which means finding a value for both variables. So now I'm going to take my value that I found for x and I'm going to substitute it back into either one of my original equations. You can pick either one of the original equations, these here. Okay, so I've chosen the bottom equation and substituted that in for x. So I've got 3 times my value of 4 minus 4y equals 8, and now this is what I'm solving. I'm solving for y now. So let's finish this out. We're going to try to isolate y here, so we're going to move some stuff away from y till we get it by itself. So we have -4y equal to -4. If we continue and we divide both sides by -4, then we're going to end up with +1. So we got -4 over -4, which equals +1. Now we have found a value for both variables. Our solution to this system is the coordinate 4, 1. Alright, I have another one to show you. Just going to sort of walk you through this one. Another system. I want to let you know that sometimes you're going to have to use multiplication on both of your equations when you're using elimination. You will have to multiply both equations by some number to create a situation where you have one variable that is the same number, opposite signs. So what we've done here, this is just one option, there are many, but we've decided to multiply the top by 4, the top whole equation, and the bottom by -3, so that we can make the x's here be the same number, different signs. See how that happened there? So once I distribute, as we saw on the previous slide, we will have 12x minus 16y equals 84. Don't forget to multiply that number you choose by all terms in that equation. And then on the bottom we have negative 12x minus 6y equals negative 18. And what that does for us is that it eliminates the x. We're using elimination. And we can now solve for y with what is left after we add these equations together. So you can see, you can continue along, work on your own and compare your answer here. You should get a y value of negative 3. You can then take that back to either one of your original equations. We chose the bottom one, but it doesn't matter. And substitute it in for y, because remember, y is what you found this time. So substitute it in for y. Continue to solve for your other variable x. You can check your work, see if you come up with x equals 3. So your solution would be 3, negative 3 this time. All right, I mentioned earlier that you can come across different situations with different amounts of solutions here. So I want to tell you why that happens. As you're doing work, you may come across a situation where you think you've done something wrong, but maybe you haven't. If you are trying to solve and you're in your solving steps and all of your variables disappear, sometimes that will happen. You start moving things, subtracting or adding, and your variable's gone. But you end up with a statement that looks something like this: 10 equals 10, or some other number, 2 equals 2, a true statement. If that happens, then this is your situation here. What has happened is both of your lines are in the same location and they have infinitely many solutions. If you're solving and you end up with a false statement, something like this, 2 equals 5, where the two sides of your on your equal sign are not equal, then this is what's happened here. This was that parallel lines scenario that I told you about, and you'll have no solutions for that system. So this is going to conclude our lesson on solving systems of equations using elimination.